Hello everyone and welcome to another tutorial. In this tutorial we are going to create a binary tree data structure in Python, and after that we are going to create the pre-order traversal method just to traverse the whole binary tree using recursion, and we are going to learn a lot in this tutorial. Let's see a representation of a binary tree. A binary tree is built on nodes. So we need to have nodes in order to have a binary tree. And this is the most basic representation of a binary tree. For example, this node, which is the root node, contains a value of 1, and then contains a value of 2, and this contains a value of 3. And then we repeat the same process, but starting with this one, with the number 2. Then this contains a 4, and then this contains a 5, and then this points to the 6, and then this points to 7. Okay, so we start traversing starting from the root node. So the algorithm says first we need to check if the current node is empty or null. So we're starting from the root node, which is this one. We check if this is empty. It is not empty. And then we need to print out the value. Then we need to move first to the left, displaying the data part of the root that we already did, and then traverse the left subtree by recursively calling the pre-order method. So we go just right here and we get to the node with the value 2, and then we print it out. And then we go to the left and we find another node which is not empty, and then so we need to print that value. We go to the left, which is not represented here because it's none, but let's put n. Here is n, so we end. So we finish traversing to the left, and then we need to go back. Let's actually use the red color. We need to go back to the fourth, and we need to traverse the right subtree by recursively calling the pre-order method, doing the same but for the right. And here is none. We go back to the fourth, and then we already checked this one. We go back to the number 2, and all this part we already checked. We already checked this part. We need to go to the right. Now we go to the right and check the node contains a value of 5, and then we need to print it. And doing the same for the left, and then for the right, which is none, and then both times go back to the node with the number 5, and then the number 5 go back to the node with the value of 2, and then this go back to the root node. And now we already completed the left side starting from the root node, and then we need to go to the right side. So we go here, we check, it has a 3, we print it out, and then we start from the left again because we are calling this recursively. We check the number 6, and then do the same. Check the left side, it is none, go back, and then check the right side, it's none, go back, then go back, and then now here the left side of the node 3. We print out the number 7, which is this, and then check for the left, is none, check for the right, is none, go back, go back, go back, and we finish. This is the result that we are going to print out. Now let's do the implementation of the binary tree. We first need to create the building blocks of the binary tree, which is a node. Let's create a class with the name node, and let's initialize it, the self and the value, and then self that value, which equals the value that we are going to pass in, and then the left side, which is for now is none, and the self.right is none. Now we are going to create the binary tree class and doing the same process. Create a constructor and passing the root node. Well, which is the root value, because here we are going to assign root to a node, but passing in the root value to the node just to create a node and assigning them to the root variable. Now let's implement the pre-order traversal. But this is a tricky method because it needs more values, because we are going to traverse it recursively. So here we need a start and the traversal. Traversal is going to be represented by a string. So this string is going to have all the values that we already checked in the overview or in the drawing representation that we saw before. The start is going to be the first node, which is the self.root. Now we're going to check if start. So if start node exists, we add to traversal. We need to add the value to the traversal variable. Traversal equals to, we need to start that value plus just do a separation for each one, for each node. And then traversal, it's going to be self.preorder traversal, but now using the start.left, because we need to check first the left side and passing traversal. After we check the left side, we need to check the right side and also passing in traversal to concatenate all the values, all the node values to traversal, and we return traversal. This is a pretty simple implementation, but it's going to work. Now let's define a main function. Let's create a tree and the number 1. Now we need to, so far we haven't seen how to add nodes automatically or programmatically, but we are going to adding the nodes by manually. I added the nodes manually. Now here I need to call the pre-order traversal and pass the root value. And for the traversal, it's an empty string. Now here are the 3 values. Now let's name it tree representation. Tree wrapper. The binary tree representation. Now print tree wrapper. Now let's call it. Oh, here's something wrong. If name main, never forget this part. Cool. So let's execute this. Here, CLS. Now Python binary tree. Okay, there's something here which is not working. Okay, I made a typo. It is not a start, it is root. Now let's execute it again. The tree representation, left, root, swan, left, right, left, right, left. There's something going on here. Okay, yeah, here we need to concatenate, and I was assigning him again. CLS, and yeah, we have it. That's working correctly.